All right, so we have a hypothesis test dealing with the proportion. We know it's the proportion. We have these, it says test whether P1 is greater than P2. We have the zero point 0.1 level of significance. And part A would be the answer for this one. Our null hypothesis is always P1 equals P2. Our alternative should be P1 greater than P2. It's a right tilt test. To determine the test statistic, we have this formula here, P1 hat minus P2 hat. Let's find P1 hat and P2 hat. P1 hat is 116 divided by 252. We don't even need to get that actually. Let me show you one thing you can do. P2 hat equals to 141 divided by 313. The pooled proportion equals to 116 plus 141 divided by 252 plus 313. We should probably find that because it's too hard. It doesn't make sense to. Well, let's see. So you get 116 plus 141 divided by 252 plus 313. 0.455. If we round to the thousandth. All right. Let's find the test statistic now. All you do is plug in. This is one way to plug it in. So you could, if you want to be more precise, you can actually plug in the exact number instead of the approximation. So 1 divided by 313. So that would be the exact answer for the numerator. P1 hat minus P2 hat. Because notice I'm not approximating to any decimal. So if I press enter, boom, there's the numerator. I could even get the denominator like this. I can press divide. So it will take that answer and then it'll divide. So you might need multiple parentheses there depending on how you guys do it and how your calculator works. But mine, when I do square root, it kind of allows me to plug everything inside of that square root. But your calculator might say square root and then parentheses, and you'll have to plug in whatever there and then put an ending parentheses. So everybody's calculator is different. This calculator is a little more advanced, so I will just do 0.455, 1 minus 0.455, and then I'll just hit square root again. So you might actually think I need a ending parentheses in here somewhere. Hold on, let me get rid of that 5, put it, insert a 5 there. Okay, got it. So I need to be careful there. So now you'll do 1 divided. So you guys have got to be careful where your ending parentheses goes. So 1 divided by 252 plus 1 divided by 313. And then I'll go to the right. I'll put an ending parentheses there to end this parentheses. Yeah, so that those parentheses go together. Press enter and I get a test statistic of 0.23. Now that's the rounded answer. 0.23 is the rounded to 2 decimals. But the exact answer is there, 0.2333423. I mean, now so watch when I find the p-value. I'm gonna be more precise, and I'm just gonna say that for the p-value. I can draw a picture like this. Put 0 in the center. I'm gonna put 0.2334. And I'm actually going to leave that. Watch when I do this. I'm going to do norm. Okay, so this is going to be like this. So norm CDF 0.2. Oops. Okay, 0.2334, comma 99. I mean, the more precision, the better here. So watch how I plug it in now. Going to say second distribution, norm CDF, and then I'm going to do this. I'm just going to go to that value, which is right here, press enter, and see how it gives me all of the digits. So comma 99. So that's very precise. I mean, how many digits is that? 9, 10? I don't know. And then press enter. So we get 0.408 if you round it. That was using more digits. Now, if I would have done the rounded version, and here just put like comma 99 and then just deleted everything, this would give me a slightly different answer, 0.409. So it's off by 1,000th. So I don't think that would actually matter on the homework because it usually allows a little bit of a tolerance. So, but anyways, the p-value is 0.408. and the test statistic is 0.23. Those are the two things you would need to find there. And that's it.